All right. It's all yours. Take it away.
All right. Well, thanks, Greg, for inviting me to talk to the AstroSig this week. My name is Casey. I'm a relatively new member to the TAAA. I've been working at Kitt Peak National Observatory as the Director of Astrophotography Programs for about 7 years now, where I developed a lot of courses meant for amateurs, having started as one in my backyard with just a Celestron C8 and suffering through the frustration of not having a lot of resources to try and learn this amazing hobby that we have. So I've been in the hobby for about 8 years, and I often get asked quite a bit about PixInsight. So when Greg was asking for topics, I thought I could talk about a couple of tips and tricks that I've run into recently. It seems like a lot of people in the group have some experience with PixInsight, so hopefully a lot of this isn't too foreign, but please feel free to ask questions along the way. I have a couple of examples of things I want to go through. First off, just being a process called arc sine stretch. And I named this stretching for effect because there's a lot of different ways that you can take an image from a nonlinear format linear to a nonlinear format. And there's several different ways to do it in PixInsight. And ArcSine is one of the tools that I think is really underused by the community. A lot of people prefer mass stretch or regular histogram transformation. But I find that ArcSine really has a lot of benefits, and I just wanted to share that with the group. So to get started, I've got two images up on my screen right now. It's Messier 101 in both luminance and RGB, and I'm going to use ArcSine on both of the master files. The only thing that's been done to these are they've been cropped, color calibrated, and the luminance has been deconvolved. So I have, during my classes that I teach and the workshop that I teach, I have a standard set of process icons that somewhat mirror what Warren Keller teaches over here on the right-hand side of my screen, but I find that it's a good step-by-step when you're going through PixInsight, especially when you're learning it. So I can make these available to anybody if you want them. I can send them to Greg after the presentation. So I'm going to do two different stretches side by side. I'm going to do a traditional histogram stretch, and then we're going to do ArcSine, and then kind of compare the example or the two, and hopefully the group will see the benefit of doing ArcSine stretching. So to start off, I'm just going to use the regular screen transfer function. This is another quick tip or trick if you're getting into PixInsight and you're not really sure how to go about stretching, but most of the time up to this point within PixInsight, you've been looking at this image preview, which is basically an auto stretch, and it's PixInsight's interpretation basically of the most ideal stretch that you would have when using histogram transformation. So as you're doing these steps to essentially what is a preview, you might think you want to have your image mirror what you've been working on this entire time, on your steps that you've done to the linear image. So if you'd like that, you can actually pull up the histogram transformation function as well as the screen transfer function. And I'm going to make sure I have the right image selected by going to RGB. So here's my unstretched image. And if I take the screen transfer function off, you can see that it looks typically like an unstretched image, completely black. But if you turn on the auto stretch, if you drag the new instance icon from screen transfer function and drop it in the bottom bar right down here of histogram, you'll notice, if I do it right, that we have a little bit of a preview of what the histogram will look like. Let me drop this into 16-bit. So once I've done that, it's basically showing me that this stretch in the preview on top is what's going to be applied to this image. So if I then take the new instance icon and drop it onto the image, voila, we have a beautiful image, right? Well, not so much. It's still an auto stretched image. So if you simply just turn off the auto stretch, you can see that there's no green underline under the image, which indicates that this image is completely stretched. And then if I reset whoops, if I reset histogram transformation, you'll see that our preview now matches what we are seeing in our histogram. And then you can do further adjustments from there using the real-time preview. You can adjust the black point, stretch a little bit more to taste, you know, whatever you'd like to do. So we're going to do that same exact thing with the luminance. And this is where we might run into trouble, because typically with galaxy imaging, you'll have a lot of high signal to noise ratio in the cores of the galaxies, because that's the brightest part. And as you can see from this image, while there probably is some beautiful detail that's hiding in here, we can't really see it in the luminance at the moment. Now, there's ways we could take care of that, but for right now, we'll just do a regular stretch, just like we did with the color. Make sure they're consistent between the two. I'm gonna auto stretch, drag and drop it to the bottom. It shows me a preview of what will be the final stretched image. I'm going to apply it to my luminance channel. So we have a luminance and an RGB that are both sufficiently stretched. Now this is where ArcSine will come in. I'm going to back out real quick and create a clone of each one so we can do a comparison of before and after. So I'll put these two over to the side. Now we have our luminance clone and our RGB clone. Alrighty, so ArcSine. ArcSine is an interesting way to stretch, because essentially there's a lot of mathematics to go on behind the scenes of what is happening. And full disclaimer, I'm an accountant by trade, so I'm not well versed in the math that goes on behind PixInsight. Really, what it's doing is holding the highlights at bay while you're stretching the midtones and low tones, so you get a more dynamic image. So you'll have better contrast in the luminance, and then you'll have more vibrant colors in the color image. So we'll start with the color, because this is where I think it really benefits most images is in the color. You can see that while we do have some color stars, they're not very vibrant, and we're getting minimal color detail from the galaxy itself. So the way ArcSine works is you pull up a preview of the image, and you're going to estimate the black point. So typically, and it's kind of hard to see over a zoom, so I'm going to see if I can mess with it a little bit to demonstrate what I'm talking about. All right, so typically this is what you would see on your screen. Is when you're estimating the black point, ArcSine is just making a best guess at where the black point of this particular image is. And typically you'll see these values that are highlighted in different colors, and that's indicating that our black point is too high, and these pixels essentially are going to be clipped if we leave our black point where it's at. So with this middle slider, or sorry, the last slider, you're actually going to slide it down to adjust the black point until those specks disappear. So on my screen, right about there, it disappears. Now here's a trick with ArcSine that throws a lot of people. It's actually a two-step process, in that you're going to use ArcSine to get your first part of the stretch going, and then we're going to finish it off with histogram transformation. So the first slider up here is your stretch factor. And this is where we're going to actually just use the slider to bring it over to the right to start stretching our image. So you could go all out and throw the entire stretch on at 100%. And as you can see, it's not really bringing out too many, it's not what we would think of as like a vibrant galaxy image. You know, the colors are great. We've got some really, really great colors in the stars, but everything's really muted. And that's what ArcSine is meant to do, is kind of hold back, again, those high points within your image so it's not blowing out and you're getting all that color, saturation, and detail. So the best way that I've found to use ArcSine is to stretch the image until you just start to see the galaxy or the nebula appear from the background. And in this case, you can see some of the detail in spiral arms. We have the core there, and the colors are looking good. So this is an appropriate stretch with arc sine. Now it's a little glitchy. Every time you try to close it the first time with the real-time preview, it tells you there's an error. But if you drop it in and do the arc sine portion of the stretch, you're then going to follow up with histogram transformation. And I'm going to bring up the RGB. Let me just reset this so it's back to normal. And this is actually the clone. So this is currently where we're at. And now the rest of the time, or the rest of the process, is just to manually manipulate the histogram transformation as if you were doing it manually on any normal image. So I'm just going to start stretching from the middle, pulling it up, and I'll apply that piece of the image, and I'm going to slightly adjust the black point, probably further stretch just a little. Oops. All right, so now we have our color data. If I pull a side-by-side image of the two, you can see that the color from the original, basically cheater method of using screen transfer function and histogram is a lot more blown out. And to make it fair, I'm just going to slightly adjust the black point on this in a similar stretch. But you can see I'm starting to clip data. Maybe I'll reduce the stretch a little bit. But now that I've got them a little more comparable, you can see, hopefully on your screens, again, it might not come across too well on Zoom, that we've got a lot better color fidelity in the stars. The highlights of the galaxy are a little suppressed, so we can further process those to bring out more detail. But really what we're looking for in color is just more vibrant color and a little bit more on the saturation side. You can see that these stars have a little bit more color to them. They don't have just plain white, essentially. Got a little bit more detail in this little knotted portion of the star forming region of M101. So we're also going to do the same thing to the luminance clone. And it's the exact same process. Sorry, Zoom likes to get in the way every once in a while. So I'm going to turn off the auto stretch and bring up a real-time preview. And once again, we're going to estimate the black point. And this, you can see that it brought up several of the clipped pixels that it highlighted. And so we're going to reduce the black point until that piece of it is gone. And then using the stretch factor on the top, we're going to stretch it until we start to see some details popping out. And again, it's a little bit different with the luminance because color, you can, usually your luminance data is a lot higher signal to noise ratio, so it's not going to take as much to stretch it, but this is a good stretch where it's above the black point. We're starting to see the galaxy appear. I'm going to apply that stretch and then finish it off using the histogram transformation. And then again, to make the comparison fair, I'll move back the black point down a little bit on the other one that was using the auto stretch version. All right. And now when you compare side by side, again, you got a lot more detail in the core that's not blown out. You still have the fainter spiral arms popping out on the edges without having to do an intense stretch. And one of the other benefits is the stars actually stay quite a bit tighter and aren't as blown out. So if we, again, zoom in a little bit on some of the stars, you're getting much more granular level of detail because you're suppressing the highlights and it's not blowing out around the stars. The stars are much smaller, which might save you a little bit in processing later when maybe you want to shrink the stars using morphological transformation. But one of the biggest benefits I find is when we do an LRGB combine, it's no longer as washed out as it would have been. I'm not going to do chrominance noise reduction because this is just an example. Sorry, I'm doing this from my laptop because I have a camera on it, so it's a little slower than what I normally would like. And I'm going to do it to the clone as well. We'll just go ahead and drop the clone on, onto the RGB clone. All right. And here you have the two images side by side and compared. Now I could probably stretch the arcsine a little bit more to get more detail out of there. But again, without having to use HDMRT, which might introduce other negative artifacts when processing, we've got more detail because the highlights were compressed while we're stretching. We can see what's in the core. In my opinion, the color fidelity is a lot better. It's not nearly as blown out. The stars are quite a bit tighter. So overall, to me, I think this is a more pleasing way to stretch the image. And then if you're working with a nebula that's like a dusty nebula, like NGC 1333, for example, you'll notice that by doing arcsine stretching, it can actually stretch the lows a lot more to bring out all that beautiful dust. So, I mean, do you guys prefer this? Do you think it's a better way to stretch the mass stretch for those that use it? Hopefully you guys like this. Cricket.
I'll make a comment if you don't mind. I use it all the time. I find it very good just because I like the star colors. And apparently that's the way the stretch is implemented rather than actually part of that particular stretch. This new, whatever it's called, dynamic hyperbolic stretch or whatever it's called, has the way to just stretch using the same technique by checking a little box that says color. But arcsine stretch is so easy and does such a nice job. I use it all the time.
Yeah, I completely agree. I've been a fan of it since it came out, and I haven't had a time to evaluate the hyperbolic stretch, but I've heard good things about that one as well. All right. So there's arcsine stretch. One of the other different stretches that I wanted to bring up was when processing a Hubble palette image. So in this particular image, we have just a typical SHO. This is part of the Eta Carina Nebula. And typically when you do a channel combination of an SHO image, you get something that's like incredibly green and just, you know, hopefully this isn't pleasing to anyone and you want to do something with it. A lot of people, when they first get started with PixInsight, will use something like SCNR just to nuke the greens out completely. And it becomes a little difficult to recover a good color balance. And what you'll end up having is those just blue and cyan narrowband images. And that's all there is to it. You know, there's not a wide range of color gamut because you've essentially killed one of the three channels by using SCNR, especially early in the process. So what I like to do, and a lot of you may already know this, but for those that don't, if you pull up screen transfer function, it always defaults to the channels, which is this top left button, which says link RGB channels. So when you do an auto stretch, this is what you get. However, if you unlink the channels and then do an auto stretch, you'll notice that it tries to balance out the channels and you get what a lot of people would say is probably a more pleasing image than just the cyan and the gold. And you have an entire color gamut with greens and blues and purples and everything else. So you have a lot more latitude to work with when you're starting your narrowband image. So again, using that little trick that we started out with, histogram transformation, I'll just bring up this is image 11. If you try to do arc sine to this, by the way, it's going to look like the green image. I don't recommend doing arc sine necessarily on a narrowband image unless you do a different way of color balancing. But if you use this trick where you drop in the screen transfer function into the histogram to get a representative image of what it was showing, you'll end up with a stretched image that's much easier to work with. Again, the color channels look really funky because it's, you know, manipulating them to get this nice color balance, but you get the entire color gamut and it's a lot easier to move forward from that point. And then one other trick while we're here on an SHO image, everyone hates the magenta stars, right? So you could use different scripts to correct that. One of the easiest ways that I've found to do it is just to invert the image. And then if you use that aforementioned screen transfer function, or sorry, not screen transfer function, SCNR, and I'm going to bring it down just a little bit and apply that. Well, the inverse of magenta is green. And so if we use SCNR to attack the greens and we re-invert the image, all of our magenta stars are now gone. And we still have the full color gamut of the original image to play with. So again, real easily, all you have to do is invert the image, use SCNR to remove the green stars, and you can see all the stars are very, very green when you invert them from magenta. Then re-invert, and you're good. Any questions on the narrowband?
Yeah, Casey, when you invert the green stars, shouldn't they turn back to magenta?
So when you have it inverted, and that's a good question. So this is where we first inverted it as green. And what we did was apply this SCNR with essentially the chrominance noise reduction tool. And it got rid of 80% of the green because that's
okay.
Yeah. So then when I re-invert it, while there still is a tinge of magenta, it's not as offensive, and that's not what your eye is drawn to.
Okay.
What about using linear fit on the HSO before combining them? And then you can just use any method you want on it without having color problems, I think.
Yeah, no, you're completely right, Alex, where you could use linear fit, and what that would do is balance all the channels to each other, which is essentially what screen transfer function was attempting to do by unlinking the channels. However, I'm not a huge fan of doing linear fit because it somewhat messes with the linear data really early on. And again, not being a mathematical expert to tell you exactly why, like I know Adam Block, for example, hates linear fit because it messes with the linear data in that phase. And so this is kind of like a cheat way around that and not having to, you know, do the linear fit function between all three of the filters that are vastly different. But that is one way to do it. And one of the reasons I would caution against that is say you have a channel that is extremely weak compared to the other two and you're trying to linear fit to it, you may be bringing down the signal to noise ratio and let's say the hydrogen just to match what your sulfur channel is producing. So that's why I just prefer to do this method. You know, whatever suits you best in your workflow, you can definitely do. I just think this is also easier. All righty. Well, I had one more tip and trick I wanted to bring up to the group. So one of the things that I struggled with when I first got into PixInsight was how to blend the images together when you have like a narrowband image and you want RGB stars, for example. So how do you take an RGB image like this and just get the stars out and drop it into this, Photoshop is probably a lot easier than a lot of methods in PixInsight to do this, but I am Photoshop averse. I actually don't even have it. I prefer to do everything in PixInsight. And so I wanted to figure this out. And as you can tell from the image on the left in my SHO Rosette Nebula, I've already pulled out the narrowband stars using StarNet, which I'm sure by now everyone's pretty much heard of, or you can use Russ Croman's Star Exterminator, I think is what it's called. It's a great effect. But the best way that I found to actually blend the stars from one image to the other is to create a star mask from the original. I back it up a little bit. I was playing around with this before I combined them. If you take a star mask from the original SHO image of what the stars look like and where they're at, that's what I've done essentially by creating this new star mask. And let me just forward all the way through to where the current version is. Oops. So I have my narrowband image and my color image, and I'm going to use a script which is readily available, and I'll show you where to get it, called Blend from Mike Reed and Hartmut Bornemann. It's usually where I get everything from. He's got really, really great scripts. I'll show you his website here in a minute. But using the star mask, if you apply the star mask image and then you bring up the blend script, this is the easiest way I've found outside of Photoshop to do it, where you can take your SHO image and you use your RGB image. Actually, before I click that, the mode that you use is something called screen or negative multiply, where it's essentially screening out where your mask is. And if I use the RGB function to blend the two, and I forgot to turn the auto stretch off, so it's going to auto stretch it too. But now you can see between the two, I've got my SHO background and I've got my RGB stars from the RGB. So fairly simple process, just using the blend module. It's meant to fit Photoshop. But by using the map from the narrowband stars, we're not bringing the same point spread function of those stars and swelling them up essentially. And you're getting a much more pleasing image. So any questions on that process? Fairly straightforward. Easiest one. Yeah. I didn't see who that was talking, but was there a question out there? No? All right. Real quick, if you want to look at those scripts that I mentioned, you can just Google Auto PSF in PixInsight, and it will go to Hartmut Bornemann's page, Sky Pixels, right here. And I believe it's Swedish, not really sure. But that blend script you can find right down here, as well as an PSF that is super helpful as well. And I can send this link out to Greg as well after the meeting. All right. So those are the couple of quick tips and tricks I wanted to share with the group. So hopefully you guys found it useful.
All right, very good. Any questions for Casey while we've got him here?
Casey, yeah, I have one question for you. On that last example, where you used the star mask and blended the stars, you showed a star mask. So you made a star mask first from the RGB image, right? And then you use StarNet to get the stars, separated. But I'm not sure what the purpose of the star mask was originally.
Sure. So the star mask was actually, let me just see if I can share it again real quick. The star mask that I created was actually pulled from the narrowband image prior to pulling the stars out.
Okay.
The reason for doing that is because when you overlay the RGB stars on top of the narrowband image, you don't necessarily have to do it that way. You can use the RGB image, like a star mask from the RGB image, but what will end up happening is you're going to have a lot more stars and you're going to have a lot fatter stars. Because essentially with narrowband, as you probably know, they're going to have much smaller detailed stars.
Okay.
Just by virtue of shooting narrowband, you know, they're going to have tighter PSFs
I
essentially.
see. Yeah.
And so that's why I was using that mask that's applied to the SHO image prior to doing that blend, because then when you blend it, you're only dropping in the stars from the RGB onto what you've already prepared as your SHO image. And so as you can see from all the several steps as I head back, like I've messed with the image quite a bit to get it where it was before, you know, because I wanted to do like a lot of color adjustments and then contrast enhancements before I was finally ready to drop those stars back in.
Right. So it keeps the stars from being over bloated.
Exactly. And so when you end up with a blend, you've got the background nebula stretched and, you know, contrast enhanced using LHE, you know, whatever you're going to do, and your stars are not affected. They're not blown out. They're just the regular RGB stars. And all I had done to the RGB image was, you know, a channel combination, a color calibration, and then stretched it. And that was it. Didn't do anything else to the RGB image because all I cared about were the stars.
Right. On your ArcSine H stretching example, do you ever run into problems with some of the brighter stars getting pink centers or overblown due to the stretching, and then maybe having to use RSV separation repair to protect those stars?
I haven't, and I think it's because I do that two-step process that I had mentioned where you're only stretching the image part way, and then you're using histogram the rest of the way. So like, again, you only use an ArcSine to really stretch it to where it's above the read noise and above the black point. And then you're using histogram the rest of the way, which kind of hides a little bit, but it's not to the extent of, say, your regular histogram stretch where you're overblowing the cores, or, you know, you're losing a lot of, or it's hidden by the high points from the stretch.
Yeah, because I know some people use multiple iterations of ArcSine stretch, and then you start running into some problems with blown out.
Yeah, and you know, like you said, that's people run into a lot of issues with ArcSine, and that's why I think it's not as widely accepted within the community, because there's several different ways that people have tried it. In my experience, just doing this partial stretch and then using histogram the way, I've never run into any of those issues.
Yeah, that's a safe way.
Yeah, exactly. You could get a little crazy and experiment on your own, but you know, I haven't run into that.
Yeah, thanks.
Huh?
The ArcSine stretch dialog actually has a checkbox that says protect highlights, and I found that works pretty well. What it does is actually almost requires it to apply it at least twice, because it really subdues the entire thing while damping down or not allowing you to stretch the highlights. It does protect them.
Yeah.
Yeah.
I also may say one more thing. I had a big exchange of emails with Russ Croman, who's a star exterminator person, and he wrote an article or did something about using the screening to replace the stars, to both extract the stars, color correct them correctly, and then put them back in. And I showed a very simple example that you don't get the same colors back in. Screening is actually a blending, as it says. and to some degree, so you blend colors from both the receiving and the donating images, and you don't get the calibrated star colors back if you use screening. Just it's close. It's really, I think the way it is, it ends up affecting the smaller stars much more than the brighter stars in terms of a color shift.
And I have seen that, but that's why I end up just trying to yank them out via, like you said, StarNet or Star Exterminator. And while you do see a little bit of that, it's much less pronounced, and you can still play around with star colors a little bit later in the process by using that same star mask if you want to adjust it if it doesn't come over quite right. All right.
Any other questions for Casey? All right, thank you, Casey. That was really interesting. A lot of pretty straightforward stuff that's going to look very useful.
Yeah, thank you.
All right. I've got a couple of announcements. You should remember that our July meeting on July 18th is the Monsoon Challenge. And again, the idea here is to go out there and get an image of M13 or M16 or both, whichever, and then present those at the July meeting. So just want to remind everybody of that. I had a email from Rick Paul, and you may remember that Rick is a photographer who's kind of heading up the project to collect some images for the buildings at CAC. And he wanted me to remind everyone to get your best images ready to submit to him so that they can blow them up real big and paste them all over the walls at the buildings at CAC. And some of those walls are going up even as we speak. So again, I think Rick's gonna try to address some more of the details about that, but he wanted me to remind folks to be thinking about getting your images together. I also wanted to share a screen. I had the opportunity to attend the Advanced Imaging Conference in San Jose last month, and all of the sessions were recorded, and the AIC committee has posted all of those recordings on their library site. So this is the list of the sessions from the most recent AIC. And apparently they've made these available to anyone who goes online there and creates an account. You don't have to pay anything for these, but you do have to create an account and then log in. And once you log in, then you can pull up any of these talks and watch the video of the presentation. And looking around, I noticed that the entire AIC digital library, which is can be linked from this same page, will take you back to any of the AIC meetings from the last 10 or 15 years, and all of the, or most of the presentations have been recorded, and you can go back and look at those. So the ones, they have some that are in tracks, so you can attend most of them. You may not be able to attend all of them, but a couple of the ones here that I'd like to point out that I found particularly interesting were the ones by Dr. Phil Plait. You may know him. He's the guy who runs the website called Bad Astronomy, and he popularizes a lot of things that have to do with astronomy, particularly things like the fake moon landing and things like that. he gave a very interesting presentation called The Art of Science and Vice Versa. Another interesting one was from Dr. Dirk Frobrich from the University of Kent, came all the way to San Jose to talk about hunting outbursting young stars, which is a citizen science project where he accepts data from color filtered images into a large database. And they've come up with some software that allows them to pretty much calibrate any image, any data that you might want to submit to them, as long as it has a FITS header on it. And even red, green, and blue images that come from one-shot color cameras if the channels have been separated. So I found that a very interesting citizen science project where you can contribute data to them. And what's really interesting is they've picked stuff that's very bright, like M42 or the Pelican Nebula, and allow people to submit their image data from those popular targets. And then they analyze the data to look for these outbursting young stars, which are many times stars that are just forming that may have planetary systems forming as well. So I thought it'd be a good idea for you to be aware that you can go to the AIC website and sign up, make an account, and then have access to these presentations. Most of them are a little over an hour, and they cover the whole range of topics, everything from the nuts and bolts of PixInsight to Photoshop to landscape, nightscape photography, as well as some other things that are much more technical, dealing with CMOS cameras and different aspects of telescopes. So I thought that was a nice touch that they made these widely available to folks who couldn't afford to go and travel to San Jose for the actual presentations. Any questions about that? Okay, anybody have any images that they'd like to share? We've got a few minutes left in the hour.
Greg, I have a question. The CAC pictures, are they only pictures taken at CAC?
You know, I'm not sure about that. I suspect that that's what they want, but you'd have to check with Rick Paul about that. And he's out of town. That's why he's not on the meeting tonight. But he'll be back probably in a few days, but I'm not sure about that. And we'll have to wait and get an answer from him.
Okay. All right. Thanks.
Okay. Any other folks got images to share? This is your chance to share your image.
Yeah, this is Mike Murray. I've got one.
Okay.
So this is the Pelican. It hang on. It was taken on a C-14 at f2. This is almost 29 hours. But what makes it interesting, it was taken on an unmodified Canon 6D. So I actually like my Canon the way it is. I'm not going to modify it, but I think you can see it still takes incredible pictures. This was processed with WBPP, and then it was processed in Star Tools. I did not use PixInsight.
And how many hours again?
Almost 29.
Yeah, that's an amazing amount of H2 nebulosity for an unmodified camera.
The kind of story behind this this picture, I was at AIC. Greg, you don't know me, but I know you. I'm sorry I didn't see you.
Okay.
I attended that one briefing by a guy named Jonathan, where he talked about how if we're using CMOS cameras, we should all be taking really short exposures.
Yeah,
And I did that with this. These were 90-second subs. It was, I forget, 11 or 1,200 of them. I'm never going to take a picture like this again. It took me 11 hours to process this in WBPP. It took up almost 600 gigabytes of memory. I did it as sort of an example to show that it really isn't practical to take really short exposures. But I thought, well, you know, I'm gonna do it and see what happens. I have another image which I'm not going to show, which was only three hours. I wanted to compare 3 hours to 30 hours, and there is way more signal in 30 hours, as you would expect. But most of us cannot afford the processing time to process an image that's constructed using, in this case, it was 90-second subs. The sharp cap formula that you use to determine these fast CMOS subs told me to use 57 seconds. And it was like, that's just too short. I'm not doing 57 seconds. So I compromised and did 90. But that was really the significance of this image for me. Again, an unmodified camera, pretty good. You know, when you blow up the daylights out of it, it's not perfect, but it's not really intended to be blown up like that. It's supposed to be looked at like this.
what was the ISO you used?
Gosh, it's whatever they recommend for that. It was either 1600 or 800. I forget. 16 probably.
Was there a lot of noise in the 90-second exposures? I imagine you got rid of a lot of the noise just by the number of exposures that you stacked, but
No, not really. I don't think there was that much noise. I'm south of town. I'm in Green Valley. So maybe darker skies than some people, but not pristine skies. Anyway, I'm still happy with the 6D. You know, people are like, geez, aren't you going to modify that? And it's like, no. Look at this picture here. Do I need to modify it? I mean, you know, I'm sure you could get redder reds if it was modified, but this is still a really nice picture.
very good, thank you.
Greg, this is Mike Mulcahy. I could show you something that kind of continues that vein a little bit.
Okay,
So Mike and I both participate regularly in the Green Valley group. We have Zooms once a week also. And one of the hot topics down there is there's a bunch of us who are, I don't know, getting kind of old or for whatever reason don't like to spend hours and hours making PixInsight images. And we've been trying to see what we can do with Star Tools. Mike noted that was processed in Star Tools. And so I've left Southern Arizona where I lived for 8 months, and I'm up in Seattle now, so I don't have my telescope with me. So all I can do is fool around with the images I have, reprocess them, and maybe try to learn some things. So I just got done with this one. These are two images here. On the right-hand side, this is the Able 2151, which is the Hercules Galaxy cluster. I'm just shaking out a new C8 Edge that I bought, and my 294 mono was in for repair, so I had to use the 183 color camera. And the right image is basically my effort in PixInsight. Both of these have Photoshop adjustments made to them afterwards. So I don't know how long it took to do this, but it doesn't have a great background. It's a fair amount of detail. It's fairly deep I think I have about 5 hours into it. And so I said, well, let me just take this same data and from the master only. I didn't recalibrate anything and run it through Star Tools. So Star Tools is on the left side. This took me probably 3.5 hours, and this took me a half an hour. You know, you just have to take my word for that. Once you get used to running down the steps, it goes pretty fast. So, you know, I can kind of get these in the same deal here, not maybe perfect, but so there's a comparable level of detail. I think the Star Tools image is much better. There's a lot of variables going on here in terms of processing skills and everything, but it definitely holds a lot of promise. And we're seeing some pretty excellent images come out just using the star tools. You can do it very quickly, or you can spend a little bit more time on it. The same concepts are embedded in star tools as you find in the kind of distributed number of tools, so to speak, in PixInsight. Things like arcsine stretch are kind of buried in careful use of its stretching tools, but I was pretty impressed with the results. Again, I will say that there's a significant amount of final curve tweaking and saturation adjustments in Photoshop on both of these. So if you're interested in exploring even a third way or a fourth or a fifth way to do image processing, Star Tools is very inexpensive. It's 40, 50 bucks, I think, and it's kind of fun to work with. So there's muddling the pot a little bit for you.
Great. Thank you for sharing that. That looks very interesting.
Hey, Greg, I've got one to share.
Okay.
Off it on here. Let me share my screen real quick. So this one actually has a halfway decent story behind it. We've all shot the Horsehead Nebula before. And this was one that took me about 2 years to do. It's a 6-panel mosaic using a plane wave CDK 14. It's about 50 hours of total exposure. But the reason it took so long, we actually started off just shooting the regular Horsehead and deciding that, hey, this would be really cool if we got the entire area at like a higher resolution. And me and my partner, who have the telescope out in Texas right now, we're going to relocate it to CAC once we build the observatory as part of the member observatory project. But once we got into it, we started it kind of late, and then we realized, the bane of every astronomer's or astroimager's existence, all the TAC over here, was just killing a lot of our images, and couldn't figure out how to process it out. And I consulted with a lot of experts that are way above my pay grade in terms of how to get some of the reflections out, and no one could really deal with what was going on. But I realized about a year later, after I had thrown in the towel on this image, that half the subs had this really bad reflection across the entire image and the other half didn't. And so when I went back and looked at the FITS headers, I realized that once we had done a meridian flip and the target was on the west side of the pier, for some reason, the light that was coming off of Alnitak that must have been bouncing off of one of the trusses on the CDK 14 wasn't at the same angle, and it wasn't causing that reflection. So we reshot another 50 hours of data, essentially scrapped the first stuff around, and I still have like 20 hours of data from the previous one, and reshot it all. And then I finally, a couple months later, obviously this is late in the season, was able to put the 6 panels together using APP and then process in PixInsight to get the final result. But it was an image 2 years in the making.
Wow. Yeah, I've heard stories similar to that where folks discover that they have this, obnoxious reflection on one part of the sky, and then all of a sudden it goes away when they flip around to the other side of the sky. So that's a good lesson to keep in mind.
Yeah, it's funny when that happens.
Hey, Casey.
Yeah.
Would making an HDR image do anything for you? 2 different exposures, one that captures that star in a shorter exposure, and then other exposures blended together.
That's a great point, Alex. We actually did try it. And so the worst offender was hydrogen alpha, believe it or not. We were getting reflections of the secondary in 4 of the panels from Alnitak. And no matter how short we went, 15 seconds, 30 seconds, I mean, the camera's a FLI 16803, so you can't really do short exposures like a CMOS on it, but we tried and it was still there.
Yeah.
It was just that reflection was killing us, and we couldn't figure out how to get rid of it other than just flipping them out, apparently.
Casey?
Yeah.
That might have been the last diffraction spike I've ever seen to the right of Alnitak.
Yeah. that was one of the things I couldn't figure out how to get rid of either. It is very long.
You think it really just a fact of the optics or something, or what?
I think so. And one of the things that I did notice is that we did have a couple where the plate solving was kind of off. And if we had centered the panels a little differently, I think it wouldn't have been as pronounced, essentially. But yeah, it is very distracting from the image, unfortunately, because you're right, it does go across almost the entire thing. Yeah, on attack is just a pain in the butt. And that's all I can really chalk it up to.
It seems like sometimes those diffraction spikes are more obnoxious when they happen to line up north and south too.
Very true.
Yeah.
Yeah, because it does. And as we had that image all the way across left to right, and that's the way the 6 panels went,
Yeah.
Like a widescreen, it is detracting because it goes across the entire image that way.
All right. Well, thank you for sharing that and the story behind it.
Mhm.
Any other images that folks want to share? All right. Well, thank you all for tuning in. It's about an hour, and I'll post the recording of this sometime tomorrow. And Casey, if you want to send me any of those links, you can. I'll try to get those out to everyone as well. Remember, next month is the monsoon challenge. So if you can avoid the clouds and get an image of M13 or M16, and be prepared to share it and tell us how you got it next month, okay? All right, thanks everyone.
Thank you.